Math 6 students. Today we're going to go over 13.3 in your math book. So go ahead and get your math book out. There's a lot of visuals we're going to be going through today as I walk you through this chapter. And actually today we're going through 13.3 part 1. I'll make a second video because this chapter lesson has been split into 2 days for me by my teacher manual. So you're going to do the work over the course of 2 days, and so I'm going to teach the lesson in 2 halves. You can go ahead and open up to page 228 in your books. And you can pause the video now if you need to go grab your book, or open up to page 228. Alright, today we are discussing histograms. A histogram is a data display that divides the range of data into equal intervals and shows how often each interval occurs in the data set. It usually is used for large sets of data. So before, in the previous lesson, you were doing dot plots, and that was showing individual data points and counting them up vertically. We're going to be doing quite similar thing with histograms, but it's going to be a range of data. Go ahead and look at this first page with me, 228, as we learn and read together. Represent numerical data using a histogram. The table shows the number of minutes 25 students spent reading for pleasure one day. So here we have a table with the number of minutes and then the frequency. The frequency is, if you remember from before, how often the number of minutes occurs in a set of data. For example, under 0 to 29 minutes, we have a frequency of 1. That means if this is a group of 25 students, only one of them read between 0 and 29 minutes. The frequency of 30 to 59 minutes, which again is that range, is 3, meaning that of the 25 students, 3 of them read from 30 to 59 minutes. And jump ahead to, if we wanted to look at the range of 120 to 149, we have 5 students. So the frequency is not going up in this table by an equal amount or going up at all. As we see it and we follow the table, which is the green one right here, it's going 1, 3, 5, 7, 5, 3, 1. It actually looks semi-symmetrical, but that's beside the point right now because it's not going directly up, and we know for histograms that kind of that horizontal axis, which we know is an x-axis, is going to be those ranges. And instead of dots, we're going to form bars. Now, in this example, look at the graph that I'm describing on page 228. Because the horizontal axis represents continuous intervals of time, for example, 0 to 29, and then picks right up on 30 to 59, we don't have like a 0 to 29 and then pick up at 47. They're continuous intervals of time, meaning the bars don't have gaps in between them. If the bars had gaps in between them, it would mean there would be a gap in time. But the bars are all smushed up next to each other, showing that this is a continuous spectrum of time. So you would make this the same way from a set of data as you would the dot plots, except it's going to have ranges instead of single points. So hopefully this doesn't feel too new to you. Let's jump on over to page 229, right across the way, back to the Learn section on blue. Choose an appropriate interval to organize data in a histogram. This is if they're giving you data and you need to make a histogram and they don't tell you what your interval should be. Reminder that that interval is kind of that little range you're counting by. So we have a lot of data points here in no particular order: 50, 66, 67, 61, 68, 59, 63, 69, 64, 73, and so on. This data is showing the heights in inches of students in a class. So they say in directions, group the data into 4 intervals and then display the data in a histogram. Group the data into 8 intervals and display the data in a histogram, and then compare the 2 histograms. Interestingly enough, we're going to start out by looking at the range of all of the numbers instead of jumping into dividing it up into little ranges that we don't know what we're doing with yet. So we're going to find the highest value in this box of unorganized information, and upon examination, it looks like 73 is the highest value, and the lowest value is 50. So that means the tallest person is 73 inches tall, and the shortest person is 50 inches tall. So the range of the entire amount of data is the 73 minus 50, which is 23. All right, so if we're going to make 4 intervals out of a total range of 23, what we would do is we would divide 23 by 4 and then round up to 6 numbers in each interval, because it doesn't really make a sense in this situation to have an interval with decimals or fractions. So if we were to have 8 intervals, we would take that total range between 50 and 73 and divide that by 8, or have 3 numbers in each interval. Now, it's okay that you're going to do some rounding there because we're filling in a range and not a particular number. So it's going to fit in a range even if the range is rounded up a little bit. All right, flip over to the next page so we can actually see the histograms they made and then compare them. This is what your page should look like. You should be looking at page 230, the purple and the green graph. This is 2 different histograms to look at the same data set. So let's dive into this. They made 2 different tables to go with this histogram. The heights of 50 to 55, then 56 to 61, then 62 to 67, and then 68 to 73. Great. So then they look back at the data, which is that big box of unorganized numbers of all the students in the class, and they see how many people fit in each different range that they decided. Well, in the 50 to 55 section, there's only 1 data point. And that person is, as we saw, 50 inches tall. Great. That means there's no one 51 inches or 52 inches or 53 inches or 54 inches or 55 inches, but only 1 person fits in the range of 50 to 55. Now, as you would guess in a typical class, we're going to have more people in the middle rather than the extreme shorter students or extreme taller students. So between 56 and 61 inches, we have 13 students. So that would include a, 59 and a, 56 and another 56 and another 59 and another 57 and a 60 and another 60 and a 59 and a 60 and a 61 and a 58 and another 61. So basically you do have to go through the data and find out how many people fit in that range. There would be 13 as indicated by our chart here. And then you would do the same thing with the 62 through 67 inch range, and then the same with the 68 through 73 inch range. Then we start graphing, but make sure when you graph, you are graphing the interval ranges and not putting a range in a single tick mark, because a range is not going to be represented by a single tick mark. A range is represented by an interval. So make sure you have your intervals like they have here, 50 to 55, 56 to 61, 62 to 67, and 68 to 73. It has to be that range because it counts for multiple numbers. And then you would go to your frequency, which should be counting up by a uniform number. It could be 1s, 2s, 3s, 5s, 20s. Here they chose 3s because we have a frequencies between 1 and 18. So they did 0, 3, 6, 9, 12, 15, 18. I'm about to sneeze. Sorry, this is embarrassing on camera. I think it's the first time, but excuse me. Okay, I think I avoided it. Wow, real life moment there. All right, and then for our intervals, we have them matched up with the frequency. So how many students were between the 50 and 55 inch height? Only one. So that would be up to 1. Like a little bar. It's kind of like a bar graph. So then we have 56 to 61, and there were 13 people, so you go up to 13 and fill in that whole bar and shade it in. And then between 62 and 70, you have 18. You'd fill up that whole bar up to 18 and shade it in. And then 68 to 73, there were 8 people, so it goes back down. Great. So let's see. The little girl with the blurb says the first bar is 1/3 the height between 0 and 3, so the frequency is 1. So they chose to count by 3s, and so they had to represent 1 by going in the middle there, just estimating the best they could. Great. Let's look at the same data with the green chart represented in 8 intervals, and it's going to look a little different. So there are more intervals here with the same total range. Remember, that's 23, the 73 inches minus the 50. So more intervals means fewer students in each interval, and it might vary a little more because we have specificity. So let's see. We can see that between 50 and 52 inches, only 1 student, which is the same as before, but that was up to 55. Now we see there are 0 students between 53 and 55 inches. There are 4 students between 56 and 58 inches. There are 9 students between 59 and 61, 6 students between 62 and 64 inches, 12 between 65 and 67, 7 between 68 and 70, and only 1 student between 71 and 73 inches. So our chart's going to look a little different, but it has the exact same setup. So we have the intervals at the bottom. Make sure you're not just doing a tick mark to represent a whole range, but in a little interval. 50 to 52, 53 to 55, etc., etc., etc. And then you match those with the frequencies. This time they chose to count by 2s, which is fine as long as your y-axis has a uniform unit you're counting by. And then they made the bars to the correct height. If you're wondering why there is no bar in this graph between 53 and 55, technically the bar is at 0, right? Because there are no students between 53 and 55. Now, read this little blurb with me at the top of 231 and we'll be finished for today. The 4-interval histogram is easier to group and draw than the 8-interval histogram, but the spread of the data is revealed better in the 8-interval histogram. The 8-interval histogram shows that the value 50, meaning the 50-inch student, is an outlier from the data. It stands apart from all the other data. An outlier, this is the pink bubble, is an extreme or rare occurrence of a value, which is usually excluded in data analysis. From the 2 histograms, we see that using more intervals reveals more about the distribution of the data. We see that most students are not close at all to the 50-inch height, so one student is a lot shorter, but that wasn't as obvious when there were fewer intervals because we had an interval of 50 to 55, and it became more obvious with the smaller intervals because then we saw some intervals had only 1 representative and some had none, making it clear that the shorter student was an outlier in the class. That's all I have for this half of histograms. Feel free, if you want to keep on a roll, to go ahead and watch my video for the next day on part 2 and just knock all of that homework out at once if you are feeling up to it, or do as the book recommends and take it in 2 chunks, one day at a time. Till we meet again.